Hi, welcome to the Shiko Math Lab differential equation problem solving section. So here is the problem we're going to solve with the trig functions involved. So we'll be sine xy, xy cosine xy dx plus x squared cosine xy dy. And with the initial condition y1 equal to the pi over 6. All right, so now let's take a look for this problem here. So obviously, this is the first order nonlinear form, and then also with the x and the y together. So it's kind of give me a very good idea. So maybe I need to do a substitution and try to break this x, y, make it linear so it's easy to solve. All right, so here, like always, I always like to just move the dx to the under the dy. So this is xy, then plus x squared minus cosine xy dy dx equal to 0. Like I said, when I first see this, and I see immediately the xy, so I will think about it, will be easier. So I just substitute the xy as my u is equal to x times y. So like always, right? So what do? We need to do here. The first thing is we need to take the derivative of the u and then replace the dy dx with u and the x here. All right, so now let's take a look at the derivative. All right, so this is du dx. All right, and the x and the y, because the y is a function of the x, so I need to use the product rules, right? So the product rule of the x, so this is y plus x times the dy dx here. So also let me highlight this. All right, so let me highlight this. This is going to reference back. Okay, so now I can try to, like I said, I want to replace the dy dx, right? So the dy dx will just be du dx minus y and then divided by x, right? Try to solve it. Okay, so then this will give me the du dx. So the dy dx equal to the du dx. Let's rewrite it a little bit. Times 1 over x and minus y over x here. So remember, my goal is to try to change it to all the u and x. So u is equal to x times y, right? So what is the y going to be? Y going to be u divided by x. Okay, so now I can replace this one as du dx times 1 over x. Yeah, right? So the times 1 over x minus x, and here the y is u over x. Then simplify more, so this is du dx times, okay, so here this is times, right, times 1 over x minus u x squared. Finally, I changed everything to the, the u and the x. And then now let me highlight this. Okay. Now I need to replace my dy dx with this, right, to my original formula. Okay, so let's see here. So now this will be sine u, right? Plus u times cosine u, all right? And then u times cosine u, then plus x squared Okay, so the x squared cosine u, and so in here, like first things here, I need to try to separate this ones here. Okay, so let's do this. All right, so here I made, this silly mistake. So this is x times cosine y. So I put a negative sign there. So this is x squared cosine u, right? Xy is u, dy replace with du dx times 1 over x minus u, the x squared. Okay, then the whole thing's here equal to 0. Okay, so now let's continue, use my algebra, try to simplify. So it's u cosine u. Then the distributive properties here. So x squared cosine u du dx times it. So I will have x cosine u over, the x squared, see here, the x squared and the x, you can cancel that square, right? So it's x cosine u. Okay, so it's x cosine u du dx. Okay, then the distributive rule minus u cosine u. That's right. So the x squared and so here this is this x squared canceled out with this x squared, right? So it's u, the cosine u. All right, so now in here, and this is equal to 0. Then we find that one good thing here is here is a negative u cosine u. So this is positive u cosine u. So that's good. All right, so now we have a sine u. All right, so we have a sine u plus x cosine u du dx equal to zeros, right? Okay, so now I can do, okay, so I can move the sine u. So this is x cosine u du dx equal to negative sine u. Now I divide by cosine u x both sides here. I divided by x cosine u, and the other side I do the same things here. Okay. All right, so here this is x cosine u. Okay. And now I have du dx is equal to negative tangent, no, not, negative tangent u times 1 over x. Now I can use the separation of the variables here. So this will be the du, and then the tangent u, and this will be negative 1 over x dx. Okay, so the tangent u. So now the next step here, we will be able to integrate both sides here. Okay, so the integrations here. Okay, so the 1 over tangent u is going to be sine over cosine, right? So it's a cosine u over sine u's here. Then you can use, this is du, du. Then you can use a u sub. So this one's here, that will be the natural log sine u. All right, so this will be the natural log sine u's here. So, okay, so here I will have, this is the ln sine u, and it's equal to negative ln x plus c, and so this will be equal to 1 over, so this will be equal to 1 over x plus c. Okay, so now I can find the Okay, so here we will say the sine u, I can take the u both sides will be equal to e to the natural log. So it will be the e to the natural log of 1 over x times ec. So the sine u going to be equal to 1 over x times c. Then sine u is xy, right? Sine xy equal to 1 over x times c. Then my initial condition is y1 equal to pi over 6. Okay, so these numbers here will be sine pi over 6, right? It's equal to 1 times c. Pi over 6 is 30 degrees, so this is 1/2 equal to 1 times c. So c is equal to 1/2 here. All right, so finally my answers here will be sine xy is equal to 1 over 2x. That's it. Okay, so this one is kind of it's not too hard, and also I think it's easy to spot. You need to use substitution because of x, y, and so the substitution will be able to separate them up and become linear and make the differential equations a lot easier to solve. All right, that's it, and I hope this help you to work on your homework. Have a nice day, and I will talk to you in the next time. Okay, bye.